Okay, I just want to introduce to you for a few minutes a new force. And the new force is called the normal force. Now, if you were sitting in front of me, I would ask you what the word normal means, because I know you've all heard of it before. And usually, the way most people use it in the world, it means like conforming to some standard, right? Like stereotypical, but what's normal, we often say, because everyone and everything is so different. But that's the traditional use of the word normal. But if you were to look it up in the dictionary, you would see it had a second meaning, and you would see in italics beside it that it said in brackets math, meaning the meaning in math. The word normal in math and in physics means perpendicular. Perpendicular. So sometimes in math, the directions will be draw a normal to the surface. And it means if this is the surface, it wants you to draw a line that's perpendicular, that forms a 90-degree angle with the surface. So the normal force is always a force that's perpendicular to the surfaces. It's actually perpendicular to the surfaces in contact. So let's go back. We've been talking about gravity, right? So if I have an object here, then we know gravity will pull it down, Fg. But all of us are objects and we're not being pulled down, right? So here one of us is sitting on our lab bench or standing on the floor, and the force of gravity is acting downward on us. But we're not falling through the floor or through our lab seat, right? So there must be a force acting back upward, and there is, and that is the normal force. Its letter is F with a subscript N for normal. Okay? So the normal force is a force that always acts perpendicular to the surfaces in contact. And we say it's the second surface, like the floor or the chair, the seat of the chair, pushing back on the first surface, which could be your feet or your butt when you're sitting on the chair, right? So here you are, you're sitting on the chair, gravity is pulling you down, but the chair is pushing back up. And as long as the chair is able to push back up with enough force, then you stay at rest. Okay? If the chair isn't able to do that, then you would fall through the chair and end up on the floor. Okay? So the normal force is always the second surface pushing back on the first one. So you put your butt on the chair, so your butt is the first surface, and the chair pushing back, that's the second surface. Now, sometimes people will say, oh, so it's really just equal and opposite to Fg. Well, that's true if the surface is level and there are no other forces acting. But imagine that you're pushing a shopping cart. Okay, so here's my shopping cart across a level surface. Fg is acting down. But if you're pushing it, we tend to push on the shopping cart handle down like this. And so part of your force is going forward to move the cart, that would be your Fx, but part is actually acting downward, Fy. So now the ground needs to push back, not with just a force equal to Fg, but it has to be equal to Fg plus the force you're pushing down with, right? These two are going down. If the cart's not going to go through the ground, then the ground needs to push up with a force equal to the two of them added together. The same might be true if you were pulling a toboggan. Okay, so let's imagine you're pulling a toboggan filled with kids, or at least two kids on it. Fg is acting down. You're pulling upward at an angle. So this is the F you're pulling with. Part of your force will be going forward to move the toboggan, but part of it is actually taking some of the weight off the ground. And so now the ground's normal force, Fn, will not be equal to Fg again. It won't have to be as big this time because you're helping it. So it'd be these two added together that would have to equal Fg. Okay? Another example of why Fn is not always just equal to Fg is sometimes our surface isn't level. So Fg would be acting straight down because that's what gravity does, but our normal force always has to act perpendicular to the surface. So our normal force would be acting this way. And so clearly they're not in a straight line, so they're not going to be equal. And another example is sometimes our surface is the wall. Imagine you have the wall and you put a textbook against it and you push in with some force. Gravity's going to be acting this way. But Fg always the normal force always has to act perpendicular to the surfaces in contact. It's going to be acting out like this. Okay? So the normal force then is a force that acts perpendicular to the surfaces in contact, and it's the second surface pushing back on the first surface. Okay? So that's our normal force. And it's going to become really important when we look at friction, which will be the next force we're going to look at. But I won't do it right now. I'll leave that for in class. Your homework doesn't have anything to do with the normal force, so you should be fine. It's a few more static questions just to get you, to make sure you got them now that we went over that little half sheet. So I posted the new file of those static questions in Teams. I never thought of giving it to you today. Okay, so it's in Teams, so please do the ones indicated on the sheet. Okay, very good.